Hi boys and girls, today we're going to do Module 4, Lesson 3 in our Geometry unit. And to do this, you're going to need your workbook, your Module 3-4 workbook, and you are going to be on page 13, which is the first page of the problem set. But before we get to that, we're going to demonstrate how to identify, define, and then draw perpendicular lines so that you can be successful when you do your problem set. So let me get set up and we will get started. Okay, I forgot to mention you are going to need a straight edge for this. You're going to need your right angle template. If you don't have one that's made from a circle, then just find yourself a nice square cornered piece of paper that you can use as a template. All right, I am going to start by drawing perpendicular lines. Now we haven't actually talked about them in terms of their actual definition, and hopefully before we're done today you will understand what it means. I'm going to draw a line segment here, and now using my right angle template I'm going to line it up against this line segment, and then I'm actually going to take my straight edge, if I can. This is hard to do up in the air. And I'm going to draw another line segment. Whoops, another line segment like that. I'm going to label my points of my line segment A, B, C, D, and I'm going to label the point where they intersect E. All right, now these lines do intersect. They do cross one another, but they intersect at a very specific type of angle. And if you take your right angle measure and you go into each of those corners, you're going to see that each one of those corners is a 90-degree or a right angle. And we're going to note that those are intersecting at 90-degree angles or right angles using that square angle symbol, not the arc, but the square. All right, so now I have line segment AE. I have line segment EC. Or no, I have line segment BE is perpendicular to it. And then I could also say that I have EB and is perpendicular to this line segment here, EC. Or I could say EC is perpendicular to ED. And I can also say ED is perpendicular to line segment AE. So I've kind of gone all the way around this figure and labeled all of the perpendicular line segments. Now the way we note that they are perpendicular is with this symbol. It's like an upside down T. That is the symbol for perpendicular. So line segment AE is perpendicular to line segment BE. AE, BE. Or EB, EC, perpendicular. EC, ED, ED, EA. Alrighty. Now over here, I'm going to draw two line segments, and they're going to intersect. And I'm going to take my right angle measurement, and I'm going to put them, let's see, I'm going to put that right angle measurement on the vertex of this here, and I see that this angle is larger or greater than a right angle. That makes it what kind of an angle? Right, obtuse. I'm going to look at this little angle inside of here, and I'm going to put the vertex of my template on the vertex of the angle, and I'm going to see that if I follow this line segment and then that line segment, that is smaller than or less than a right angle, which makes it what kind of angle? An acute, right. Now take a look at this angle. Match up my vertex with the ray. If I follow this ray, this line segment and this line segment, I see that this is larger than the 90-degree angle, or obtuse. And then if I line up my template against this last angle, and I follow this line segment, and then this line segment out, I see that it's much smaller than what that 90-degree angle would be. These lines that form an X are just merely called intersecting. So even though these lines also intersect, because they intersect at this very special right angle, they are called perpendicular. Now, if I were in the classroom with you right now, I would pause and I would let you up out of your seats, and I would have you take your template, and I would have you look around the classroom and find find angles that were perpendicular, like on the windows or from things hanging on the wall, or look down at the floor. Are there any kind of tiles or in your cabinets, any kind of right angles you find? And actually, I would love to hear what some of those right angles are when you do your problem set, and I'll give you directions on how to do that for me. Okay, so now that we know what a perpendicular line is, and the difference between that and an intersecting line, we're ready to start our problem set. Now, the problem set has a lot of pages, so don't be put off, but I think you're going to find it's fun. So what we're going to do on page 13, on number 1, on each object, we're going to trace at least one pair of lines that appear to be perpendicular. So you're going to need your right angle template, either a piece of paper with a square corner or your one from a circle. You could use a highlighter, you could use a crayon, or you could just go over it with pencil. I'm going to go ahead and use a highlighter. So on this first shape, I'm going to line up my vertex on the vertex of this angle, and I see that indeed I have a right angle, which means that this ray is perpendicular to this ray. So I'm going to trace that with my highlighter. But when I look at this angle, if I take my right angle template, these two lines are not perpendicular because this angle is much greater than a right angle. And if I look at this one, I'll do it this way. I find that this angle is smaller than a right angle. But take a look at this brick wall. I see lots of square corners. So let me measure 2 of those that could be right angles. Yep, I got my template, I line it up, and I see that this side is perpendicular to this side. So I'm going to take my highlighter and I'm going to trace it. And then I'm going to look at this little brick in here, and I see that that little line is perpendicular to the longer line in the brick. So I'm going to carefully take this and mark it like this. Because I know that one is perpendicular, I can look and check all the others. That would take a long time. All right, so I've got 2 for there. Let's take a look at the clock. Well, I know the circle isn't going to have any perpendicular lines, so let's take a look at the hands on this clock. If I match up my right angle template, I see that yes, indeed, they are perpendicular because they meet at a right angle. On this note paper, if I look down in the corner here, I see that that is a right angle. All right, so you get the hang of it. You can do that with all of these shapes here. Now, question number 2, how do I know those lines are perpendicular? What do you think, boys and girls? How did I know they were perpendicular? What do perpendicular lines have to have? The lines meet at a right angle. That's how I know that they are perpendicular. In number 3, in the square and the triangular grids below, so this is the square grid, it has some squares in it, and this is the triangular grid, it's made up of triangles. Use the given segments in each grid to draw a segment that is perpendicular using a straight edge. So not only do I need a straight edge, but I'm also going to need my template. So I'm going to take this first segment here, I'm going to line up my right angle template on the segment, and then I'm going to lay my straight edge against that, and then I'm going to draw my line segment. And I'm going to do the same here. I'm going to line up my template, put down my straight edge. For you boys and girls at home, you might want to rip this page out of your notebook in order to make it easier for you to draw these lines so that they're not all bumpy. So there we go. Same thing with here. If I take this and I line it up, oh, I noticed that there's a line in this grid that's already perpendicular. So I'm just going to go over that. And let's check this one. No, I don't see any. So I'm going to take my straight edge, line it up, and I'm going to draw that perpendicular line. All right, that's all there is to that. Let's look on the next page. We don't want to run out of time. We are almost out of time. But use the right angle template that you have to determine which of the following figures have right angles. And then mark each right angle with a small square, like this. And then write down which line segments you decided were perpendicular. So this one's done for us. They said that line segment AB is perpendicular to line segment BD. I'm going to just check their work with my template. And yep, I agree with them. So now let's go over to shape B. I'm going to check all of these corners and angles to see. Well, HL is not perpendicular to LK. HL is not perpendicular to IH. IH is not perpendicular to IJ. IJ is not perpendicular to JK. JK is not perpendicular to LK. So, this one has none. Let's try shape C. I put my template in this vertex, and I see that, ooh, I have one. I see that line segment EG, right here, EG, is perpendicular to line segment E, what is this letter? F. So EG is perpendicular to EF. Let's take a look at D. Does D have any angles at all? No. So we can just go ahead and skip that one. Take a look at E. I'll do E quickly. Or no, I actually won't. Because we're almost out of time. Mark each right angle on the following figure with the small square. So I have to go around and check each angle. And every time I have a right angle, I'm going to mark it with a small square.